All right, so let's continue on. So let's see if this vector here, if this b is, or sorry, if this u can be spanned by the columns of A. So is U a linear combination of the columns of A? So that means I'm going to do an augmented matrix. So I see there's going to be two variables, right? So it's going to be x1 times the vector A1, x2 times the vector A2 is going to equal this vector U. So putting together the augmented matrix, negative 2, 6, 4. 1, 1, 4. Okay, so remember, we haven't used it too often, not that I recollect, that we can switch rows, right? So I'm going to switch the rows. I'm going to put this 1, 1, 4 up here, and I'm just going to move these two down. And the reason I want to do that is I want this 1 here for the pivot. Okay, so now I'm going to multiply negative 3 times row 1 and add it to row 2. And that will get me a 1 in this position, right? And then I'm also going to take 2 times row 1 and add it to row 3. So lots going on. What does that give me when I do that? I can keep the first row the same. Then the second row turns into this. And the third row turns into this. All right. So now I see that I can add row 2 and row 3. 1, 1, 4, 0, negative 8, negative 12, 0, 0, 0. Okay, I don't need to go further because what I can see is that I'm going to get a solution, right? So I can see that this row right here, so let's just give you, I just want you to think about what you see. I wouldn't do any more algebra, but I would say this gives me negative 8, x2 is equal to negative 12, so I will get x2 as equaling number. And then this first row up here, this would give me x1 plus x2 equaling 4. Well, I have the x2, so I could find the x1 as well. Okay, but I'm not going to go do that because all I need to do is answer the question. Is U in the plane? Is U being spanned by? And because I can see that this is consistent, I have a consistent system here. So consistent, so yes. U is in the span of the columns of A. All right, so moving on. Okay, so I'm going to be talking about how to multiply matrices. So how to multiply this matrix here, which is a 2 by 3, times this vector, right, this column matrix or column vector here, which is a 3 by 1. So I take these entries here, so this 1 multiplied times this 4, plus this 2 multiplied times this 3, plus this negative 1 multiplied times this 7. Then I add those together, so 4 plus 6 minus 7, that gives me a 3. So I do the same kind of thing, so I take each of these entries and multiply it times each of these columns. So 0 times 4, plus negative 5 times 3, plus 3 times 7. And those added together give me a 6. So this is a 2 by 3 matrix. This is a 3 by 1 matrix. These numbers need to match in order for the matrix multiplication to happen. And this is the size of the matrix that I get out of it. All right, let's look at this again. So here I have this row. It's called a row vector. So I multiply this row times this column vector. So 2 times 4 plus negative 3 times 7 gives me a negative 13. And I do the same thing here. So I multiply this row times this column. 8 times 4 plus 0 times 7. And then negative 5 times 4 plus 2 times 7. And add those together. And this is the column vector that you get out. That is a 3 by 1 vector, right? It's a 3 by 1 vector. All right, let's look at this unique matrix, which has 1s in the diagonal, and you were multiplying it times RST. So let's see what happens when I multiply this row by this column. So 1 times R plus 0S plus 0T, well, that just gives me an R in that first entry. Same thing here, 0 times R, 1 times S, 0 times T, that gives me an S. Same thing here, 0 times R, 0 times S, 1 times T, So I get the same column vector out again. So you can think of this matrix here as 1 in matrix land. Okay, so just making sure you know, if I'm going to multiply two matrices, a B and a C, these have to be the same number, and what you get out of it is an n by m matrix, and if it does not exist otherwise. All right, this is a really important, really important, did I say that? Really important theorem. So this is all about the matrix A, which is an m by n. Remember what m by n means, right? So there's m rows and n columns. Okay, so this is the coefficient matrix only. It's not the augmented matrix. So all of these are true or all of them are false. So for each b in Rm, Ax equal b has a solution. For each b in Rm is a linear combination of the columns of A, so it's in the span. Oh, and that's what this says. The columns of A span Rm. Oh, and this is a big one. A has a pivot position in every row. Okay, so this is about the coefficient matrix, not the augmented matrix. So make sure we know that. All right, so we'll go on to the next video to start playing with that.